Here we go, chapter 6-4. Pretty easy section, but you do have to apply all the rules that we learned in the previous two sections. So when do we add exponents? When the bases are the same and they're attached by multiplication. When do we subtract exponents? When the bases are the same and their bases are attached by division. When do we multiply exponents? When there's a power to a power, you multiply the exponents. Okay? Now, what we're learning today is rational exponents. A rational number is any number expressed as a fraction. So what we're dealing with are fractional exponents. So if we have fractional exponents, you need to understand that there's a numerator and that there's a denominator. The numerator is going to be your power. Your denominator is going to be your root. So you have heard me say power over root before. The power goes to the base as an exponent. And then the root goes inside as the index. So power over root. Okay? If you have a negative fraction, the negative must go to the numerator as the exponent, not as the root. We all understand that. You can never take a negative root. Yeah, I can't have negative 2 square roots or negative 3 square roots. I can't have that. Okay? So here we go. I want to take these problems and I want you to write them as radicals. So I'm going to eliminate the fractional exponent. Very first thing I want you guys to do is to write the square root symbol. What is the base of this problem? X is the base. The base goes inside. What is the numerator of this fraction? 9 represents the exponent that is going to go on the inside with the x. What is the denominator of this exponent? It is a 2, and that is the root, and that goes here. Do I need to have that 2 there? No. No, so this is the square root of x to the 9. That's all you guys are doing. These two things are equivalent. X to the 9 over 2 is the same thing as the square root of x to the 9. Pretty sweet. Yeah. Nope. Next, same thing. So we want to go from a fractional exponent to a radical. So I'm going to have my lovely little root symbol. What is the base? X goes in the inside. What is the power? 3. 3. And what is the root? 4. I am done because the 4 has to stay. Now, this problem right here has a negative exponent. So where did I say the negative goes? The negative must go in the numerator with the 2, and the 3 is positive. So now we're going to do this exactly the way we did before. Here's your root. What is my base? What is the power? And what is the root? Done. This is so cool. It is very cool. Math is extremely so easy. X to the negative 1.4. My time. My time. X to the negative 1.4. That is a decimal. We don't do decimals. What do? Fractions. So the 4 is in the tenths place. So this is x to the negative 1 and 4/10. What does 4/10 reduce down to? 2/5. So this is x to the negative 1 and 2/5. That's a mixed number. I want an improper fraction. So do the C rule. 5 times 1 is 5, plus 2 is 7. So this is x to the negative 7/5 power. Do we all understand what I just did there? Okay, now we do exactly the same procedure that we did before. I draw my nice little radical symbol. My base is x. The power on that is negative 7. The root is a 5, and I am done with that problem. Do we understand how to go from a fractional exponent to a radical expression? We good? Okay, now let's do the opposite direction. I give you a radical expression, and I want you to write that as a fractional exponent. So, what is the base of my lovely problem here? X. What is the power? 5, and what is the root? So it's x to the 5 over 2. If you don't see any root there, it's understood to be a 2. Okay. Then next, how many bases do you have in this problem? 2, you have a base of 5, you have a base of y, correct? So that means I'm going to have 5 and a y, and I have to look at the powers. The power on the 5 is currently a 1, so that's going to be a 1 over the root of 3. Do you see that? Go to the y. The y has a power of 4 with a root of 3. So that is 5 to the 1/3 power times y to the 4/3 power. And this is done. Okay, how is the next example different than this example? It has parentheses. When it has parentheses, it is lumping the two bases as one. Do we all understand what I just said? It is lumping the two bases as one. So my base that I'm utilizing is 6y. The power on the 6y together collectively is a 3, and the root is going to be a 2, and then this is done. Do we all understand that? Yes or no? You must put the parentheses around the 6 and the y together because they had an original problem as such, and they're treating it as one base. Okay? Okay, next. Now let's actually apply the information. Now I want you to simplify the expression 64 to the 1/3 power. For our brains do not like exponential functions. Our brains do not like fractional exponents. So we're going to go back to the radical expression. So Harley, what do I do here? Would 64 go into the So I have 64 as my base, and what is the power on the base? 1, and what is the root? 3. So now I'm asking you, what number multiplied by itself 3 times is 64? 4. It is 4. Done. 4 times 4 is 16, times 4 is 64. Do we understand that, yay or nay? Okay, let's go to the next one. 3 to the half times 3 to the 1/3 times 3 to the 2/3. How many different bases do I have? So I have one unique base. I have 3 things being multiplied together, but they all have exactly the same base. So like I said earlier when I reviewed, when you have the same base and they're always after multiplication, what do you do next? You add them. So this is going to be 3 to the 1/2 plus 1/3 plus 2/3. Now you can do this any way that you want. What is 1/3 of a candy bar plus 2/3 of a candy bar? A whole candy bar. So I have 3 to the half times 3, or I should say time plus 1. I skipped ahead of my head. What's 1 1/2? 1 1/2 is the same thing as 3 over 2. Yes? A half a candy bar plus 1 candy bar is 1 1/2. 1 1/2 is 3 over 2. Now, how do I write this as a radical? Here's my base. Power is 3. Base is 2. My root is 2, yes? Now, my power of 3 is not divisible by my root of 2, so I'm going to break it down so it is. That's going to be 3 squared times 3. Yes? Square root of 3 squared comes out as a 3, so this is 3 square roots of 3. Now, I would like to show you something. Are you ready? Mm-hmm. You should not have had to have done 3 or 4 steps there. When you had this right here, your brain should have said, oh, well, 3 to the half times or plus 1 is the same thing as 3 to the half times 3 to the first. Yes? So 3 to the first is just that, and then 3 to the half is the square root of 3. Done. And if your brain can't see that, then you do it the other way. That's the beautiful thing about mathematics. It doesn't matter how you do it, as long as you get the right answer and you can justify what you did. Does that make sense? There are multiple ways to do these. As long as your brain picks one method and understands that method, and you can justify your work, I am let's go ahead and start today's homework. Yes. You don't want me to do your homework? I need it. There's so many fucking problems because I do have them in the rest of you. Alright, here we go. Number 3. The directions say write each expression in a radical form. So all you have to do is do radical form. So how do I do that? I put the square root symbol. My base is t. What is the power? And what is the root? Done. Do we understand 3? Number 4. M to the 2.4. What is 2.4? 2.4 is going to be 2 4/10, which is 2 2/5, which is what? 5 times 2 is 10, plus 2 is 12/5. So my problem is m to the 12/5. How do I rewrite that as a radical? Put the check mark symbol, put the base of m, the power is 12, the root is 5, done. I'm sorry? 2.4 is 2 4/10. Okay. Yeah. Do we all understand that first section? Go to the next section. The directions say write each expression in exponential form. So if I'm writing this in exponential form, look at number 6. How many bases do I have? I have 3 bases, but they are in parentheses, so how many bases do I technically have now? 1 base. So I'm going to keep that base in parentheses, and my exponent is a 3, and my root is a 4, and I am done. Number 8. What is this going to be? N is my base, my power is 4, my root is 5, so n to the 4/5. Any questions over the first 8 problems? Okay, let's go to number 10. Problem 10 says to simplify each expression. So how many bases do I have up there? I have 3, but they're all the what? The same base. So what do I do with the exponents? We add them. So -5 raised to the 1/3 plus 1/3 plus 1/3. A third plus a third plus a third gives me 3/3, which is going to be -5 to the first power, which is just -5. Yes? Okay, let's keep going. Number 13. 18 to 1/2. What does that mean? I don't understand that 1/2, so I need to put it in a radical form, right? So this is going to be the square root symbol, 18 to the first power. The root is 2. It's understood to be there. Square root, 98 is my base. Power of 1, root of 2. Do I need the 1 and the 2 there for either one of those? I technically do not. So I'm going to marry these two together. 18 is going to be 9 times 2. What is 98 divided by 2? 49. 49 times 2. So now, what's the square root of 9? What's the square root of 49? And then look, I have a pair of 2's, and that's going to come out to be a 2. So what is 3 times 2? Times 7? Times. Pretty cool, right? Yeah. Turn it over. Number 16, write each expression in simplest form. Assume that all variables are positive. What does that statement mean? Assume that all variables are positive. You do not need absolute value bars. Now, if I'm looking at number 16, this is -27 in parentheses raised to the 2/3 power. Does my brain understand fractional exponents? And understand them, who does it like to think of? No, so we're going to translate this and put it into a radical form. So I'm going to have the root symbol. Negative 27 is on the inside in parentheses. My power is a 2. My root is a 3. Now, answer this question. If I take any number and I square it, what happens to the number? It's positive. It is positive. What else happens to the number? It gets much larger. That's you. What if I take a number and I take the square root of it? What happens to the number? It gets smaller. Does your brain work better in larger numbers or smaller numbers? Smaller numbers, unless we're talking about our bank account or our paychecks, right? Now, with that being said, we're not talking about our bank account or our paychecks, so our brain works better working with smaller numbers. So the beautiful thing about fractional exponents is they're attached by multiplication, which means multiplication is a commutative. It contains the commutative property into it. 5 times 2 is 2 times 5. Doesn't matter the order that I do the multiplication, I'll still get the same answer. So, do I want to take the cube root of negative 27 where I'm going to get a smaller number, or do I want to take negative 27 and square it where I'm going to get a larger number? Which would you prefer to do first? Take the cube root of it. So, what we're going to do is we're going to take the cube root of negative 27 first, and then we're going to square that number. So, what is the cube root of negative 27? What number multiplied by itself 3 times is negative 27? Come again? Come again? Negative 3. Then I'm going to square that. And what's negative 3 squared? 9. Tell me this. Did anybody have any issues with that calculation except for the negative part? No, we already knew it. But does anybody know what 27 squared is? Off the top of their head, is that a calculator? Nobody knows that. But you do know how to do this. So work smarter rather than harder. Okay? So with that being said, let's go to the next one. What's 7 to the 0 power? 0. It is not 0. It is always and forever 1. Number 21. The number is so small. You are going to add them. So this is y to the 2/5 plus 3/8. What's the common denominator between 5 and 8? 40. What are you going to multiply 5 by to get 40? 8. So actually, what you have is multiplying this by 8. What are you going to multiply 3 by? So 8 times 2 is plus 3 times 5 over 40 to give me 31 over 40. Do I expect you to be able to do that? No, just type it in the calculator. You'll be able to punch out 31 over 40. Now here's the beautiful thing. 31 over 40 is as reduced as it goes. Would you agree with me? So now we simply take it from fractional exponent and write it as a radical. So I have my radical symbol, my y is my base, my power is 31, my root is 40, and I am done. Gotcha. Okay, 23. What do you notice about 23? How many different bases do you have? You have 3 bases there. They're not the same on number 23. They are together, but they are not the same. So that means you have to put on missing exponents. The missing exponent that I'm missing is on the 3. So now what am I going to do with that 2 on the outside? You're going to distribute it in. So this is going to give you 3 squared. A to the, nope, half times 2 is going to be 1. B to the 2/3. What is 3 squared? 9. And then I'm going to get rid of this fractional exponent by writing as a radical. So I put my check symbol there, my radical symbol. B is my base, my power is 2, my root is 3. I'm done. 25. Same exact concept. What do you do first? Put the missing exponents on. So So this is x to the negative 2/3, y to the 2 over. What's that going to give you? 4/3. And then y to the negative 1. 4/3. Yeah, like my 3? Okay. Minors, yes. Right? Now, what do you do with your lovely little exponents now on your x's? Subtract them. So that's x to the negative 2/3 minus 4/3. Y to the 2 minus negative 1. Negative 2 minus 4 is? Negative 6/3. Plus plus is y cubed. What is negative 6/3? Should I stay or should I go? X goes to the bottom, the y stays on top. I am done. You guys have the rest of the period to work.